Okay, can't fit the entire page on the screen, but we're now on the top of the third page. We have to match, let me go down a little bit further. We have to match the slope fields with their differential equations and then draw the solution curves. Okay, so working our way through, what do we go across? When there's repetition going horizontally, that is our y only, all right, a differential equation which only has y involved. So that means that it's going to be either a, d, or f. All right. Now, again, there's multiple ways to go about it. One way is, well, what do you see? Well, I see up 3, so somewhere right around here, I am drawing the solution. That's our regular e to the x. So the derivative must be equal to the function. Well, what about the point, graph number 2? All right. So once again, we have repetition going across. Okay, so this is a y-only differential equation. Well, we have two y-onlys left. And when y is 4, here we should have 0 for our slope. Well, if we go up, here's 4. Those are definitely 4 squared, which is 16, plus 1, which is 17. So we need some pretty close to vertical slopes, A. If we draw the solution curve through the point 2, 3, so over 2, up 3, somewhere in this range, what's happening? Well, we're skyrocketing up in this way. As we come down, having that type of curve. Okay, the slopes are leading to the next one. All right, number 3, equal to x. Oops, there we go. All right, dy dx is equal to 0. Well, this one's just on here, so our graph flattens out, and then it hits the one slope line. In this direction, it's skyrocketing up. We're looking at a graph, a solution curve, something like that. All right, let's swipe up a little bit. I've used A, D, and E, which means I've got B, C, and F left over. All right, well, let's go to F, since that is, again, our final horizontal repetition. This does not have repetition horizontal. Match with F. Okay, the solution curve over 2, up 3, somewhere in this, going down like so. Okay, that leaves 2 functions left. I'm going to swipe up quickly. B and C, one is x, the other is sine x. All right, my detectives, let's look at these two. Which one of these sort of mimics some kind of trigonometric curve? Absolutely, that would be with B. If we go over 2 and up 3, we're in this regard, and we're looking at a trig curve, a nice wave, some kind of cosine curve right there, because the antiderivative of sine would involve cosine. And then finally B over x, which means our original function is a quadratic, which means that we should have a parabola, which we now do. All right, so there's your curves for the top half. So for dy dx equals x plus y over x minus y. Which one and why? All right, well, I've got so on the area where y is equal to the opposite of x, I should have 0 slopes. Now the line y equals opposite of x is this line right here, going on the diagonal from left to right. This graph definitely does not have 0 slopes going left to right diagonally. This graph definitely does have 0 slopes going left to right diagonally. All right, and this graph line. So our answer is B.